complexity that we see here.
Our campaign is coming to an end, but new ones will continue exploring, making new discoveries. Our journey is not over. Keep watching. This is just the end of a new beginning.
My name is Sara Morales Serrano. I'm system engineer for Clean Space, and today I'm going to try to explain you what is the problem of the space debris and what do we do at ESA to solve it. So space debris is any man-made object that is in space and that is no longer functional. As you know, we have been sending spacecraft to space since the 60s when the space flight started, and not all of them have re-entered and have left the space free. So there are two main orbits that we occupy with these satellites that are the low Earth orbit, what is considered one important region that is highly populated, and there we send our mission, for example, for Earth observation, where we can see how the Earth environment is evolving, or we can do, for example, weather prediction to know which is going to be the weather tomorrow. But also there is other orbit, like for example the geostationary orbit, that has some characteristics that are very particular, that they are all the time on top of our head. So they are very good for doing telecommunication, so for example to have our TV at home, or to use our mobiles. Nowadays we have 5,000 satellites, more than 5,000 satellites in space, and only 2,000 of them remains operative. We have lots of rocket bodies, so parts of our launcher that have remained in space, and some events have created even more debris. These events are, for example, collision between two spacecraft that have generated a big cloud of debris that is orbiting the Earth, or also some other events, like for example, self-explosions of our satellite. How do we take care of the environment here on Earth? So what we do is to try to assess all the environmental impacts of our missions during the whole life cycle of our mission. So since the beginning that we are developing our missions until the end of life. And we take into account all the phases like manufacturing, the launch of the spacecraft, and also the operations of our mission. So for this, we use a methodology that allows us to calculate what are the environmental impacts here on Earth. Like for example, in climate change, all our emissions that we have to soil and also to the water, and all the possible toxic materials that we use in our spacecraft. And the aim is to try to find alternatives that are greener and then they are polluting less to the environment. We also try to take into account the environmental impacts in the orbit. So for this, what we do is to try first to reduce the number of debris that we are creating and to remove the ones that are already there. So first of all, what we need to do is to leave free this space of the orbit, so remove the debris from this spot that was occupying during the lifetime. And we have requirement that states that we have to re-enter in the atmosphere in less than 25 years after the end of life. This is for the low Earth orbits, but also for the geostationary satellites. They have a similar different requirements depending on the size of the satellite. If we are a big satellite, we will go to an uninhabited region in the Earth. Or otherwise, we try to maximize the disintegration during the atmosphere, so we design our satellite in a way that will disintegrate faster. We still need to do some actions in order to prevent the creation of more debris. And there are studies that show that we have to remove at least 5 large objects per year in order to stabilize the situation. For this, we have been studying during the past year several tools that allow us to remove the debris that are in orbit, like for example the nets that are like a fishing mechanism. It works in the same way. So we will drop a net around our spacecraft of our debris, we will grab it, it will be enclosed inside this net, and then we pull it back to the Earth to burn up in the atmosphere during the reentry. Another tools that we have studied is an harpoon. We shoot this harpoon against the satellite, so then it will go through it, it will capture it, and then we do the same way. We will re-enter our spacecraft. Then other tools that are more sophisticated and can help us to do future servicing in orbit could be the robotic arm that will go closer to our target, it will grab it, and then once it grabs it, it will bring it also back to the Earth to burn up. These are several tools, there are many more that are under study, and now at ESA we have our first mission that it has been announced, that it will go to grab one of these part of the launcher that is in space. We will grab it and bring it back to Earth. So as you can see, there are many things that we need to do. We have to start now, and this is what we are trying at ClearSpace. Thank you very much.
Hi, I'm Matt Mellis. I'm an aerospace engineer for of the 3 clips that you're going to see in just a few minutes. Now, and Kevin, thanks for being here today.
Glad to be here, Matt.
What you're going to see is what I consider to be the best of the best state-of-the-art imagery on both film and high-definition video that the Space Shuttle program is capable of producing today. And not only does it serve a technical purpose, and we'll get into a lot of that detail as we get into the movies here, but it also serves as an enormous inspirational and educational aspect for all of NASA's stakeholders. There's a number of intents that we have for this production, and one of them is to pay tribute and commemorate the shuttle program, which has essentially been a 30-year program, and it's nearing completion as we go to final print with this production. We also want to pay tribute to the men and women that made all of this imagery possible over the years of different missions and launches that we've had, and also to give a view that not very many people see outside the NASA family of these fantastic pictures that are used largely for engineering purposes, and to let everyone on the outside of the NASA family have insight as to